Oh, see, well, you can shout them out anyway. You found it? Okay, well that was superbly interesting, Mike. I like it. Especially because I've had problems with dark matter. We've all had problems with dark matter. And now we've got no problem with dark matter. Anybody got a question? I see silence. Well, I don't hear any silence. Anybody?
How open is the mainstream community going to be to this new approach?
Well,
use the mic to come back on.
Oh yes. So I've managed to publish 21 papers so far in mainstream journals.
Wow. So are you getting support?
Well, it's quite interesting that journals tend to accept my papers, but I get the cold shoulder at conferences.
Right.
So I don't really understand it.
Maybe it's just it will take time, I guess.
Maybe, yes. It could be that the journal process has an editor overseeing it, and they tend to keep it nice and polite.
Yeah.
At least he's getting some publication though.
Yeah,
but, you know,
fantastic.
I think he's had a bit more opposition from conferences than you can imagine that the way he's described. You know, that's yes.
Any more questions?
There's resistance. There's a question over here.
Oh,
okay.
I guess it's two. One, you submitted something to Nature magazine last year in 2017, and they didn't accept it, but they accepted it by somebody else. Did I hear that correctly?
No, it's very similar to what you said.
Use the mic.
I submitted a paper proposing that an observation would be a good test. So
okay.
I said that ancient galaxies should spin faster for the same mass, and they rejected it, which I really expected anyway, because I've never published in Nature. Anyway. But then a paper was published showing that exact observation, not explaining it, but just saying ancient galaxies spin fast.
Okay. And is this a theory? Are you challenging theories? Well, okay, how's this going to change the game? If you're correct.
Which game?
Well, the fact that you're arguing against dark matter, I mean, everyone here is, but just, I mean, what's the edge? What's the edge that you have here?
I suppose the edge is that I can predict things that are useful. Because
Okay, that's the question I'm asking.
The only real interest I've had is from the military. So,
And why are they interested?
because it is potentially useful.
And how useful? Like, give me an example.
Well, a thruster. It would enable launch without dangerous, expensive chemical rockets.
Oh, okay. Now it gets interesting.
So, any more? Well, of course, it's micronewtons at present, but if it could be more.
If you understand
space, you can have flying saucers.
Can we hear what Walt has to say about this?
Yes. Walt or Don?
I didn't have a question simply because I don't think it's an answer. The approach in the electric universe is that the gravity is the electric force, a particular kind of electric force, and it has nothing to do with electromagnetism. Whereas you're talking electromagnetism with tiny thrust. The electric model of gravity shows that it reverses the direction of the Earth around the Sun every 6 months. That's 6 by 10 to the 21 tons by 210,000 kilometres an hour. That gives you an idea of the gravitational force. Now, if we can defeat gravity and not play with electromagnetism, we do have a possibility of cancelling inertia and also achieving real thrust. People wonder how UFOs behave the way they do. The only way they'll do it is by cancelling inertia and using the gravitational force, not playing with electromagnetic waves. So I don't have a question. Also, of course, the dark matter is not required because it's electromagnetism that is the functional aspect of the motion in galaxies. It has very little to do with gravity. The plasma cosmologists already determined that with particle and cell experiments where they utilised electrodynamics and showed that adding gravity to the model had no effect. All you need in that case is the direct electric force.
Okay.
I think this also shows that introducing quantum mechanics, which has no physical explanation, it's a recipe, is not the way to go either. The results will be, whatever they are, will be trivial by comparison with understanding gravity. Sorry.
I think there's very interesting stuff in the galaxy rotation curves, whereas the
light and
yeah, there's that stuff, but you come up with a V as root R, which is true in the intermediate parts of galaxy, but late in the outer parts, V as a constant happens, which is in fact something which Mike says would follow from his theory. So if you have an overlap between the two ideas, that does seem to have some credence.
Don could explain that. The light also is due. Pardon me.
Do you want to answer?
No, I'm fine. We have a competing ideas.
Oh, the two of you?
No,
No.
me and this gentleman here.
Oh, okay. Do you want to say something or not?
Well, just that my view is that there is no need. There's no need for dark matter. Dark matter is becoming, of recent times, very, very controversial even among astronomers. There's a fellow named Stacy Gaw. He's the head of the astronomy department at Case Western University. He's gone out on a limb and said there's no such thing. And
Well, Mike agrees with that. There's no such thing.
say again?
Well, Mike agrees there's no such thing.
Yeah,
as dark
no,
matter.
so I'm saying that yes, and my view is that the rotation curves of the stars in galaxies is caused by the Birkeland current rotations that feed, or at least at one time fed, those galaxies. That's where the spin comes from. Astronomers are very, I said this before, so I'm sorry to repeat myself, but I feel very strongly about this, that the astronomical community talks about the Big Bang and all sorts of things, but they have never addressed the question of where does the spin come from? The only thing that naturally spins in the universe is the Birkeland current.
Shall I
Very good.
answer that way? I don't get beaten up on it.
Hold it closer to your mouth.
Yeah, so the only test is what predicts the data with the least human input. So I've shown that with just the speed of light, the Hubble scale, and the visible mass, all of which can be seen and measured, I can predict galaxies exactly. So, but I haven't, it may have been done, but I haven't seen the electric universe model do that yet. So I guess I'm asking.
The paper was published this year, April.
Yes.
Okay.
The other thing is that change in the light curve would also be expected under the Birkeland current explanation because that signifies where the current density is greatest as well. So that's not a mystery, I think. I could ask Don about that, but since it's his model. I think the other aspect is there are all sorts of things mentioned in there, like the Hubble constant. Well, the Hubble constant doesn't seem to be a constant either, and it's just an artifact of the misinterpretation of redshift, as I mentioned before. And it's also an artifact of the Big Bang model. So there are a whole string of prior assumptions which are sort of cantilevered on one another, which end up with the standard model now. And addressing the standard model, or using anything from the standard model as a basis for a new theory, is, in my opinion, prone to be fruitless. That's all I can say.
Pass it back.
Yeah, well, I think it was obvious to all of us that we're not going to agree, but I think kudos are due to having the courage to look for alternate explanations than what the mainstream is looking for. I think we have respect for that, just in methodology.
Any more for any more? How are we doing for time? There's someone back there? Did they approach the military or did
they came to see me.
She's going to need the mic. Yeah, she needs the mic. Speak. Hold the mic.
Sorry, so what was the catalyst, do you think, for them doing that exactly? It seems like a tiny thing, of course.
It was the, well, I'm guessing really, but I think it was the M drive. I published 20 papers, and I published lots on galaxy rotation. But as soon as I was able to predict something that had a potential utility, the M drive, then they became interested.
I've seen lots of things with potential utility just go, I mean massive utility, like balls that just go psh. So I'm not sure what I'm still not grasping what they saw as, whoa, that's so useful. I apologise if that sounds terribly rude, but I don't follow math, blah blah blah, except I know that was a tiny force, I can see that.
It's not really the fact that it's a tiny force, it's the fact that I've proposed it can be scaled. Yes, it can be hugely magnified. Because once you understand a process, if I'm right about the understanding, you can control it. So I think that's what they saw in it.
Very good. I look forward to seeing it happen.
So are we near the end on this? One more. If you give him the mic.
So with the M drive, presumably, if I were NASA, I might be thinking I could pop one of these on the back of a spaceship and fly it to the nearest star. It might be a small force, but incrementally over a long period of time, would give a lot of speed. Is that the idea?
Yes, the great thing about the M drive is it doesn't require a reaction mass. So usually, to make a rocket, you have to kick something out of the back at a high speed, so you'll go forwards. So you need to carry a lot of heavy fuel. But with the M drive, you just need a solar power. So
you don't need to have a huge tank full of liquid hydrogen or something.
That's right. So you can launch a very light object without a huge rocket attached. And it'll go between the stars as well, because as long as you put an RTG or some sort of generator on board, it will continue to thrust.
What about space debris? With something flimsy, that distance.
Why?
Space debris, well, one of the earliest uses for this is supposed to be satellite station keeping.
Okay, can we work it on two more? This microphone. Thank you very much, Mike.
Have you finished?